This is the review for Chapter 3 test in Algebra 1. And I know this is very spread out. It's not quite as many questions. It's about 25 questions, but it's very spread out. So pause if you need to write all these down, because here we go. Okay, now we're going to start talking about the standard form. That's what the first three are about. So they give us the equation y equals negative 4x plus 3. And the instructions say determine whether each equation is linear. Write yes or no. If yes, write the equation in standard form. So as far as whether it's linear, we just look for the things it can't do. Like you're not allowed to have exponents. We're good there. Not allowed to multiply two variables times each other. Good there. Not allowed to divide by a variable. Good there. So that means we are linear, so we can say yes to that part. It is linear. Since it is linear, we should be able to write it in standard form. So just a reminder, standard form looks like this. ax plus by equals c. Your first step when you want to get, or first process when you want to get standard form is to get things in the right place. So what I mean is you want the x and the y over on the left side, and you want the x term to be first and the y term to be second. So we'll add 4x over to this side because y is on the correct side but x is not. That gives me 4x plus y equals 3. So now everything is in the correct place. We have the x term, the y term, and the constant. Then we want to just make sure it's not breaking any of the rules about the standard form. For example, this number is not allowed to be negative. Y can be negative, this could be negative, but the number in front of x cannot be. So no problem there, we have a positive 4 in front. We also have to make sure there's nothing that every number could be divided by. That's true. Other than 1, there's nothing that goes evenly into 4, the understood 1, and 3. And we have no fractions, so it doesn't break any of the rules. So this is our standard form. Okay, number 2. They give us the equation x squared plus 3y equals 8. So the first question is it linear? And we would have to say no, because linear equations cannot have cannot have exponents. They can have variables. They cannot have exponents. So the answer is no, it's not linear. Okay, 3. They give us 1/4 x minus 3/4 y equals -1. So this already has things in the right place. Remember, we're going for ax plus by equals c. We have our x term, then our y term, then our equal sign, then a constant. So that does check out as being in the right place. But we have fractions, which we're not allowed to have in our final answer for the standard form. To get rid of the fractions, we have to multiply everything by their denominator, which is a 4. So I multiply this term by 4, multiply this term by 4, multiply this term by 4. So here the 4's cancel out, leaving just 1x. You can write 1 if you want to, but you don't have to. Here the 4's cancel out, leaving minus 3y. -1 times 4 is -4, and that's our answer. So make sure you remember the standard form and how to get into it. So now we're flipping over to the back of the chapter. I think it's in the chapter review section. Getting there right now. It's under the lesson by lesson review is what it's called. And we start with number 11. This is the switch to page 213 and beyond. This says find the x-intercept and the y-intercept of the graph of each linear function. Okay, the x-intercept always happens where y is equal to 0. So I'll show you the table. If you look at the table, you're looking for where the y is equal to 0, and that's right there. So that makes the x-intercept -8. So I'll say it once again. The x-intercept happens when y equals 0. So we look at the table, we find when y equals 0, that x value is the x-intercept. Now for the y-intercept, we just do the opposite. The y-intercept happens when x equals 0. So we're going to look at the table again, look for when x is equal to 0. That's right there. Our y value is 6. So the y-intercept is 6. So when you're asked to find the x-intercept and the y-intercept in a table, look for where the other variable equals 0. You'll find the x-intercept where the y is 0. You'll find the y-intercept where the x is 0. Okay, number 12, we're going to look at a graph. So remember what x and y-intercept mean. The x-intercept is where the graph, the line, in this case the blue line, intersects or crosses the x-axis, which is this one. So that's at 1, 2, 3. So this point right here is its x-intercept, because that's where the line crosses the x-axis. Its y-intercept is where y crosses, where the line crosses the y-axis. So here's the y-axis, here's my blue line. It crosses at -1, -2. So my y-intercept is -2. Okay, next up we're asked to graph the equations. At this point, I'll switch over to graph paper. Give me just a moment to grab that. And on the test, I will tell you whether to graph it by using x-intercepts, y-intercepts, or a table. They don't specify it on this, so I'll just tell you what I would recommend. But if you do it a different way and get it correct, then that's completely fine. So 13 is the equation y equals -x plus 2. So I would recommend on this one that we'll use a table. Remember, tables, when we choose some x's, plug it into the equation, and find out what y is equal to. So choose some easy ones. So I tend to just choose 0, 1, and 2. So if I plug 0 in for x, I get 0 plus 2. 0 plus 2 is 2. So my ordered pair is 0, 2. So I'll go ahead and graph that right here. 0, 2. Now if I plug in 1, you have to make sure you don't forget the negative sign. -1 plus 2 is 1. So I have the ordered pair 1, 1, which is right here. Then I plug in 2, so I get -2 plus 2, which is 0. So that is this point right here, 2, 0. Then you draw a line through those 3 points, put arrows on both sides, and you have successfully graphed the equation. I know the directions state the domain and range. You do not have to do that. Okay, 14. We have x plus 5y equals 4. I'm going to recommend we solve this one by finding the x and y intercepts. So remember, to find the x-intercept, we plug in 0 for y. 5 times 0 is 0, so we just get x equals 4. So I know on the x-axis, the line is going to hit 4. Now to find the y-intercept, I'm going to plug in 0 for x. So I get 0 for x. So 5y is equal to 4. I'll divide both sides by 5. That gives me y equals 4/5, or you could write it as y equals 0.8. I think I'll give you all whole numbers on the test, but we can estimate just fine. So 0.8, that's just below 1. So it's the y-axis just below 1. Then I draw a line through those 2 points and have graphed this equation. Okay, 15 is a better example for doing it with x and y intercepts, as you'll see. It'll come out a lot nicer. So to find the x-intercept, we plug in 0 for y. So that goes away. 3 times 0 is 0, giving us 2x equals 6. So we divide both sides by 2, get x equals 3. So the x-intercept is on the x-axis right here at 3. Now for the y-intercept, plug in 0 for x, giving us negative 3y equals 6. Then we divide both sides by negative 3. We get y equals negative 2. So our y-intercept is at negative 2, and we'll draw a line through those two dots, and we have our line. Okay, 16 would also be an easy one to do the the x-intercept and y-intercept with, but just for practice, I'll do the table on this one as well, because it's good to remind you also that when we are doing a table, we have to get y by itself. So that was already true in number 13. Y was already by itself. But if it's not by itself, like in 16, we have to get it that way. So I'm going to subtract 5x from both sides. That gives me 2y equals 10 minus 5x. Then I have to divide everything by 2. So I get y equals 5 minus 5 halves x. Okay, for the sake of space, I'm going to put the work for that on here. So 16, I'm going to create a table. We have 5 minus 5 halves x. So I recommend when you have a fraction as a slope, instead of doing 0, 1, 2, you can do that. You'll just get fractions and decimals, and nobody wants that. Whatever number is in the denominator, count by that number. In other words, instead of going up 1, 2, 3 or 0, 1, 2, start at 0 and then go up by 2's. So 0, 2, 4. If that was 5/3, I'd go up 0, 3, 6. So just count by whatever number is the denominator. So I do 5 minus 5 halves times 0. 5 halves times 0 is 0. 5 minus 0 is 5. So that gives me the ordered pair 0, 5. Now I'll plug in 2. 5 halves times 2 is 5. 5 minus 5 is 0. So we get the point 2, 0. Then we'll plug in 4. 5 halves times 4 will give us 10. So we get 5 minus 10 is negative 5. You can type that in your calculator. If you're not able to do it in your head, that's okay. So 4, negative 5. So I'm going to graph these 3 points on the graph. So 0, 5 right here. 2, 0 right here. 4, negative 5 right there. So then we draw a line through those 3 dots. And we've successfully graphed these 4. Well, I just did some extra, so that's good news for you. You didn't have to do all of those, so I just gave you some extras. Enjoy. Anyway, let's move on to number 19. So 19, we're finding the zeros. So f of x equals 4x minus 24. Finding the zeros is actually the same thing as finding the x-intercepts. So you find the zeros when f of x is equal to 0. So f of x is the same thing as y, so I just plug in 0 for that. Now I solve for x. So I'll subtract 4x from both sides. Get negative 4x equals negative 24. Remember that minus sign comes down as a negative because 4x minus 4x is 0. 0 minus 24 is negative 24. Then I divide both sides by negative 4, and I get x equals positive 6. So the 0 of this function is at 6. Okay, I'll actually try to do the correct ones now. 21 f of x equals 6x plus 3. So we plug in 0 for f of x. I'll subtract 6x from both sides. Divide both sides by negative 6. And that will reduce to negative 1/2. Or if you did negative 0.5, that'd be fine too. Okay, 23. F of x equals 21 plus 3x. So I plug in 0 for f of x and solve for x. I'll subtract 21 from both sides. Get negative 21 equals 3x. Divide both sides by 3. We get negative 7 is equal to x. Last one in this section, 25, f of x equals, oops, if I write it correctly, 25x minus 225. We plug in 0 for f of x, subtract 25x from both sides, and we divide both sides by negative 25. And yes, you are allowed to use your calculator. So if you don't know that just by looking, that's okay. You'll get x equals 9. So the 0 of this function happens when x equals 9. Okay, now moving on to the next section, 27. They asked us to find the rate of change in the graph. I'll show the graph in just a second. Rate of change means slope. So don't forget, anytime they ask for the rate of change, they're just asking for the slope. Now, let me get my paper over here. When they give you a graph and mark 2 points, you can just count either up or down, then over. So I'd recommend you always start at the point that's on the left. So we can count up 1, 2, 3, 4, 5, 6, 7, 8, 9. So we counted up 9. Put that number on top of the fraction. So we got it up 9. Then we have to count over 1, 2, 3. So the slope is 9 over 3, which we can reduce to 3 over 1 or just 3. You can leave the answer as 3 over 1 or 3. Either one's fine. Don't leave it as 9 over 3 though. You've got to reduce. Okay, now 28. What we do is we look at how the y is changing. Sorry, delta. The triangle is the Greek letter for delta. It means change. So we do the change in y over the change in x. Well, if you look, the y is not changing at all. So there is 0 change. It just goes negative 3, negative 3, negative 3. So the change in y is 0. X goes up 2, negative 2 to 0. So 0 over 2 equals 0. So that's 28. When the y doesn't change, the slope is 0. If the x doesn't change, then the slope would be undefined. So the slope here is 0 because y does not change. Okay, still dealing with slope. 29 asks us to find the slope between 2 points, and the 2 points are 0, 5 and 6, 2. So just a reminder that the slope formula is y2, let me write it this way, m equals y2 minus y1 over x2 minus x1. So for this one, y2 is 2, y1 is 5, x2 is 6, x1 is 0. Gives us negative 3 over 6, which reduces to negative 1/2 for the slope. So slope and rate of change are the same thing. And then for number 30, our ordered pairs are negative 6, 4, and negative 6, negative 2. So y2 is negative 2, sorry, no comma there, minus y1, which is 4, over x2 minus x1. Negative 2 minus 4 is negative 6. Minus a negative changes to plus a positive. Negative 6 plus 6 is 0. Okay. So when you have 0 in the denominator, that means the slope is undefined. As I mentioned earlier, when y isn't changing, which is what was happening in 28, the slope is 0. When x isn't changing, see how it's the same both times, the slope is undefined. This would actually be a vertical line that this is creating, whereas this one would have been a horizontal line. Okay, now with 32, I'm going to get a little closer now, I think. Okay, with 32, I don't think that did a good job. That's much better. Okay, 32, we're switching to slope-intercept form. So they tell us to write an equation in slope-intercept form if we have a slope of 3 and a y-intercept of 5. So remember, the slope-intercept form is y equals mx plus b. So you just write y. The slope is 3. The y-intercept is b, so you put 5 in for that. So that's truly all you have to do to write the equation. Now next, they want us to do the graph. I think, in my opinion, that's repetitive, sorry. In my opinion, this is the easiest way to graph when you have the slope-intercept form, because all you have to do to graph is say, I'm going to start with the y-intercept, which is 5. That's my first point. Then I look at my slope to figure out the next point. 3 is the same as 3 over 1, so it's going up 3 over 1. So I go up 1, 2, 3 over 1. I have 2 points, I can connect them, and I have my line. Okay, let's do 34 now. On 34, they tell us the slope is 2/3, and the y-intercept is 3. So we follow the same pattern, y equals mx plus b, so y equals 2/3 x plus 3. So it's that easy when they give you the slope and the y-intercept to write the equation. You just plug in the slope and the y-intercept. X plus 3. Okay, so this is 34. Y equals 2/3 x plus 3. So just like last time, the first thing we plot is the y-intercept, which is 3. So it's right there. Then we get 2/3, so up 2 over 3. So I go up 1, 2 over 1, 2, 3. I connect those dots and I have my line. Okay, on 36, they're asking us to graph the equation, then state the slope and the y-intercept. So I will do 36 and 38 on graph paper. Okay, so on 36, they give us y equals 4x minus 2. Just like before, we start the graph with the y-intercept, which is negative 2. If it's a minus, that means it's down, so it's negative 2. The slope is 4, which we can put at 4 over 1. So we know from there we go up 1, 2, 3, 4 over 1. Connect the dots and we have our line. And they want us to identify the slope. Well, remember, the slope is always the number with x, the 4. The y-intercept is always the number that's a constant, the one's by itself, so that's -2. So our slope is 4, our y-intercept is -2. Now we'll follow the same process for number 38. Y equals 1/2 x plus 1. I start the graph at the y-intercept, which is 1. And the slope is 1/2. That tells me to go up 1 over 2. So starting at the y-intercept, I go up 1 over 2. So this is the slope, and this is the y-intercept. Slope is 1/2, the y-intercept is 1. Okay, number 40. Going to read it aloud. Hopefully you have your paper, or your book to read it from. So it says, write an equation in slope-intercept form for the total cost of skiing for H hours with 1 lift ticket and ski rental. Then there's a little image that says Apache Slope Ski Lodge. And they say the lift ticket $50 a day. And then ski rental is $10 an hour. If you look, the problem says skiing for H hours with 1 lift ticket. So we're only going to buy 1 lift ticket. So that's a constant amount. So we're using the y equals mx plus b. So the b, the y-intercept, is always how much you start with. It's whatever is constant and not changing. That's the lift ticket. We're just going for 1 day. So that's $50, period. That doesn't change. So that's what we put in for the y-intercept. But the ski rental, that cost is going to depend and vary on how long we actually use the skis. If we go out for 2 hours, it's $20. If we go out for 8 hours, it's $80. So it depends on how many hours we're there, how much we'll spend. So for that is our slope. Anytime you see a per, so per hour, this is also per, but they told us there'd only be 1 lift ticket. It said that in the problem. Whereas this could be any number of hours in 1 day. So we do 10h. If you put x, I wouldn't be picky, but they said to use h for hours. So our equation would be y equals 10h plus 50. So whatever is constant, just a one-time fee, goes in for b. Whatever's changing, and it's per hour, per unit, per day, per dollar, not per dollar, per item, whatever, that's what you put in for the slope. Okay, now we're jumping over to graphing absolute value. So number 69, we have f of x equals absolute value of x plus 1. Okay, so when we are adding or subtracting inside the absolute value, that means it's a horizontal move. And when we add it, it moves it to the left, which may feel backwards, but you just got to remember it's backwards. Adding shifts it to the left. So instead of the vertex, this is the shape of absolute value. This is the vertex, the corner. Instead of being at the origin, it's gotten shifted to the left 1 unit. Okay, 72. We have a very similar one. F of x equals x plus 2. Absolute value of x plus 2. So that's going to shift it to the left 2 units. So remember, inside the absolute value, it's a horizontal shift, either left or right. Okay, whereas 73, I'm going to use a different color pen just so we can not have to use a whole other sheet in just a second. So 73, it's absolute value of x minus 4. So this time the adding or subtracting is happening outside. When it's adding or subtracting inside, it's a horizontal shift. When it's adding or subtracting outside, it's a vertical shift. So this is telling you to go down 4. So instead of the vertex or the corner being the origin, we go down to the -4. We make that the vertex. So that meant right 2. This one meant down 4. Next, jump to number 75. That's g of x equals the negative absolute value of x. When there's a negative in front of the absolute value, that means it flips it upside down. So there did nothing to shift it or move where the vertex is. There's nothing added or subtracted. But instead of it going this direction is an upward v, it's going to be a downward v and go upside down. Last one. 76, g of x equals the absolute value of x plus 7. So once again, when it's added or subtracted outside the absolute value, then it's a vertical shift. So this is going to shift it up 7. So we're going to be all the way up here at 7 and put the v way up there.